Hi, hello everyone. My name is Stefan Georgiev. Principal Product Manager in Microsoft. I have been working on the next team, or for those of you who don't know, the equivalent of RDP, VNext, something like that, for the last 2 years, where we're trying to build we're trying to associate RDP with a new platform that has all the capabilities of RDP, while at the same time leveraging some of the things that we are going to see today, right, both the server side and the client side. This is awesome, so amazing. Thanks to all of them. And we just want to do that. This was the first question that I had, what is the like output, right? So historically, when we were in the business of visualizing user experience, right? And what does the user progress to? They go to the logos, right? And some random PM in Microsoft about 3 years ago said that don't build like logo, right? You won't be able to tell the difference between what is in the cloud being delivered through a protocol, right? And what's something local. It didn't matter, because in the cloud you have the GPUs, the NPUs, and can you use that to actually get you even better than like local, right? So in my working definition and expressing my engineering is the way is that it has to deliver 4K 60 FPS at 30 Mbps, right? That's the definition I know. And this is why I actually presented this last year in Room B, which I accidentally went to. Today we can deliver that today, right? If you have a GPU on a dedicated GPU, it also go like $1,000 or so, right? Amazing. Stop what I say. You can deliver that today at 16 Mbps, right? With RDP, with HADC, but it's expensive, right? And then at the same time, if you get like a less than 30% latency, this is just simple latency, right? Things are amazing. You can tell the difference today. But guess what? Nobody has that, right? Or few of us have that, a little bit more precise. And what we're trying to do is how further down you can move all this continuum of experience, how much further down you can move the bar of what's the vision like of right? If you have, let's say you don't have 16 Mbps, let's say you have 30 Mbps, can you deliver with a 4K 60 FPS? And that is the goal of the efforts that I've been doing the last 2 years in Microsoft. So let me just go back for a second. So we're trying to deliver a 4K 60 FPS, but we want to deliver over here 15 Mbps, right? That's it. That's what we're doing. Now, how do you do that? And I'm used to it's physics, right? We'll get to that. But here's the reality, right? There's still some stuff out there. It's all about stealing. It's all about stealing games. It's all about stealing videos. It's not about stealing what they call the information worker, right? Info worker, right? Text. People like when the text is delivered, all the expressed, right? All the metrics that are out there today, all the frameworks, all the algorithms, they optimize for, like, even in Microsoft, we have super resolution. Amazing. It's technical term for text, right? It's great for games, it's great for video, but it's great for natural images, but it does not work for text, right? And to help solve that, this is the big plus here. We introduced in Microsoft these 4 codes that represent 3.5. That represent what we perceive as the information worker workload, right? They don't care about video, they care about text, they care about the chroma, they care about the latency, when they type, they also delay, right? They don't care if the video is blurry or how to put it longer. They about certain the products, right? And we find this performance. And then we went and did a bunch of work about, hundred engineers at Microsoft, went and built a bunch of stuff based on those profiles. Then the other thing is this is a very simplified example of a Legoland pipeline. Right? Stuff happens in the cloud, somebody renders it, usually the explainer renders it. Then that will be a GPU, CPU. We are agnostic, but it doesn't matter. We capture that, we encode it, magic happens all the time because we don't control. And then on the client, you have the code, then you can, this is the new thing that we're trying to introduce, like constituents like partner from HP and our structure, like 96 gigabytes of memory, right? Can we use that, right? To achieve better performance, right? By running some models locally that optimize for the experience, so we can get that 4K, 60 FPS, 444 white global experience that you don't get with today's protocol. And then we want to measure it, right? It's a brief slide. I mean, most of them, I don't know everyone here, I know some of you. I think we can agree on 444 maps, right? Because that's also, like, if you want to map item, or you iPhone, or whatever you're using, you don't get anything like, oh, it's equal to 0, like, I just had a learning, or text is, it's a little weird when you're looking at, like, blue or red or something like that, right? And that's what we're measuring against. But then, when you compare 444 against 4 to 0, it goes into that bandwidth compensation. It's 2 times the bandwidth that it takes to be before, right? And that's not cool, right? It takes bandwidth, but it's expensive. So we're trying to figure out how we can not give you 444, but then you cannot tell the difference. Right? So we're trying to trick you in a way with what we've been trying to build. And how do we define that, right? Because going back to my previous statement, we have a bunch of metrics all together. We have CMOS, some BMOS, a bunch of metrics defined for weather radiation that I remember, right? And they're amazing for video, right? They don't handle text. So about a year and a half ago, we decided we're going to define our own. We're going to build a new metric. It's called CMOS for visual work experience when it comes to text, to the content, right? It was about a year ago here, we kind of announced that. Now we actually have it. We're going to make it publicly available. And so, be there. The other thing is, like, it's very easy to measure something like that in a lab, right? You have your endpoint, you have a server, you have a magical cameras in between that capture the content, the frames, also the way. We won't be able to deduce that from telemetry, which is a fancy word of saying, like, if tomorrow probably comes in like next, you gave me that 10 weeks of, like, it wasn't good enough. I should be able to go to the session in telemetry and be able to say, yes, you're right. Your quality, your perceptual visual quality was 5 and was supposed to be 20, right? Because like, yes, it's great, but what happened when there were artifacts in the frame, right? What happened if there were, like the text that we were talking about, was not crystal clear, right? That today is not captured by anything. We have the remote desktop protocol, it's not captured by any emails to 65, and we will build something about it. We also publish a dataset that has captured raw 444 content, and we use that to baseline everything we talk about here today. Right? And the goal of our visual multimedia was to be able to say, like, you have something like that, right, which is an idea of a sort, and not everything needs to for disease, right? It's actually what the green boxes are made for. And we want to be able to capture that, analyze it, and tell the pattern, tell the migration, right? It was for the data share. And yes, sir.
What's the blue?
What's the blue? The blue are those of them we cannot sure if it's supposed to be 4.0. I'll get that into in the following slides. We have a little bit of a deeper dive. By the way, quick disclaimer. All this will be available with the bottom for the half to self-host. I have forwarded the slide. If you wanna self-host, let me know. And we'll get you a free GPU in the cloud, and you can figure it out. Okay, so we did produce this I hope this is still correct, Microsoft clean content dataset. So we have captured those three workloads like the previous one of the previous slides, like the fancy workloads. We did use those workloads like an automated where they repeat the load and run against the different network, different hardware, different performance, different encoder, different decoder. And I don't think it's available yet as of today, but we're going to make it available. So anybody can get that data set, and somebody like me can go grab that data set, run it against I know. I was thinking about it was doing this. They'll be able to run that against whatever protocol is, whatever hardware is, whatever environment is, and be able to use the biggest visual documentary, we also go to the library, and say, I got an A. Is A good? I don't know. We'll base that, right? But I can say like that visual documentary, it's a combination of like 10, 12 different existing metrics plus essentially where we actually have an ML model, we're training with film feedback to be able to detect. We now have this also in destination trains with the destination train. Can you actually tell the difference, right? So that's why we brought this session. All of this actually we're talking with the healthy type of AI, non-generative stuff. So actually we're using that to train models that allow us to do this method, this library that eventually we will install to everyone, and we can do that. So this is a performance, right? We will be able to measure it. So this is like a
already ready from the previous section. User delivers 4K output resolution and updates frame rate 6 frames per second before beginning the render process. It is disconnected from the cloud TCP and returns about 30 minutes later to try to complete the render. The user is able to view the output on 4K monitor and first 60 FPS is the connection to the vision bar.
So this is the latest stuff, right? This is the current stuff, right? What we will be doing today. Also build the directly with March in the Netherlands. We install this like within 68 areas with HGCD. We can do anything with big small is where we can detect which parts of the screen are text, which parts of them are natural images like videos. So this is very today. You can get this today. The problem is that again, you need a GPU, and the GPU has not changed the range. 500 bucks a month. So let's do that cheap. We want to make this better. Bunch of videos. Now, I'm going to go back to what I said already. 444 is amazing. It's what you get in your device. But it is super expensive when it comes to bandwidth, right? It's super expensive when it comes to capture on the server. Because guess what? In my world, things are running in Azure, right? And things are run on hardware that has limitations. And if you try to do 4 users 444, well, that's sort of like doing 8 users 440, which one's more expensive, right? The 4 users 444 is more expensive than the 8 users 440. Right? So if you can reduce the requirements of the hardware on the server side, we can then translate those costs to the user. So a $500 GPU, which we use the 65 accounts, let's say 250 or less. And this is one of our solutions where we have built this partner in NVIDIA and NVIDIA. We have given them the requirements to allow us to use like a single neuron. It's a content abstract in a sense, right? And you look down on the bottom, right? This is intentionally, this is images, right? And we will not be able to tell the images didn't care that much, but we care about text. And progressively, to the next 3 frames, right? We're able to give you more and more details on the text, right? We call it Superman, that's not the patented name or anything like that, or name. And the idea is like, on the server we capture photo zero. Then very quickly, very efficiently, we can run this like 3 frames, that's like 48, that's 48 seconds. We can figure out where for the next frame or for the frame number 4, we can tell you, ignore the rest, just this power pieces, right? And we do that on the server, right? And there's a thing like there's a bunch of stuff we can do on the server when we react, we have a GPU, there's a bunch of stuff we can do on the lab. So this is on server, and we can tell the encoder, focus on these areas, do those 444, ignore everything else, right? We can do those 440. And again, the idea is that by the time the user sees it, they don't want to have anything about it, right? They look at the text, it's crystal clear, right? They look at the pictures, they don't know the difference, because as in this example, they're zoomed in, or zoomed out, sorry, and once they take a picture, we'll be wrong with the whole logic, and then look at this, this is the cool part. We set this as an alpha channel information, right? So, one thing about IP historically has been that we don't commit to a particular frame rate, right? And if you today open your Windows 365 PC and you connect, it depends, exactly, right? With this thing, we are able to use that, because the code is more than static, we're able to use the information that you don't perceive, but you get, right? You get the endpoint, and it's amazing, right? So that's one solution we have. Like I said, in about 1.5 months, you'll be able to sell all of this and tell them how it works. This is what I said, that's a lot of success in 4K 60 FPS. Rarely, actually, when we ran a study in Microsoft, I used one of those generative AI techniques that was supposed to anymore. Robot EUCtech that I gave to the bunch of people in Microsoft, 99% of the time, less than 1% of the screen changes. Right? Yeah. If you're doing that information overload type of situation, right? And then if you do the way, let's say, worst case scenario, where well, 1% of the time, the worst case scenario. The rest of the time, you are the green line. And you say, what if we use that delta between the green line and the yellow line to super hard so we can do 444 and lower band, right? Because we're already using it, which is also, we already did it and we weren't using it, right? Now I say, let's use it, it's there. So that's one solution. The other thing we're doing is simple plan, right? Imagine that all the time, I mean, the laptops and the device that we have today is super powerful, right? I have a whole PC with an NPU, like almost like, why do we don't use that to do something like that? Again, this is like hypothetical about and that's the thing that we have, we can show you. But imagine that I can tell you right now, on the server, the protocol, it's smart enough to tell you, you have an NPU, or you have a GPU. Let me use that. to recover some of the missing information. Why is it missing information? Because now I'm like a super millennial node, this guy, he has this stuff, encrypted faster, encoded faster, so we can send the faster letters, so the latency is low, right? And then on the line, we are building a model that's going to run the current part of the Windows machine learning libraries, where we run these flows, the GPUs, we are using already to recover the missing information. What was different this time? Historically, we didn't have a super resolution, but those models were built for streaming, gaming, streaming videos. Now the models are trained for text format, going back to user profiles, going back to the workloads that we define. So we can do something, which is it's another solution for recovering the one. We can also do noising where we deploy processing and decoding on the server. So we can introduce noises of them, then we can move all the class up. That's what I just explained about the this one. So here's another method. It's up to them, right? But users will able to like a last conference and introduce to engineers. You cannot sacrifice test content. People complain, right? This is because we have like a lot of stuff to listen to everybody when also the like all the modules that they blue or black or red or actually people do they notice. And we want to build we have built those models that are able to recover that locally and the next generation of classes that we want to ship at one level to that. The noising, here's another example right here. You can't really tell. That's what I'm assuming. And I mean, you can see like it looks okay for English, but guess what? 90% of the world doesn't do English as their, right? They do other languages, like they do Chinese and they do other 444. It's a technical, we can use that. Here, at the bottom, like 10 minutes ago, they were using, you can see it makes a significant difference in the world processes. That was a new, as well as popular, right? Another example of the noisy, and by the way, this is like about 9 months ago, so we've gotten much better on this one, on the noisy. Another example, I think we are using the latest method with the method that we built, the machine better, how the text displays. And here, let's see if this is not playing. So this is an example of the protocol that I'm studying with the different component that we built. And sorry about that. It's a demo because that's all music. But on the left side, I have today AE with the GPU, running HTC with 5,000 packets. And on the right hand, yeah. This is supposed to be playing. Let's start again. I think it's moving on. So, with the new protocol, we were able to handle this. This is just like what we learned about the long ago. We're able to handle 5% packets. This is false synchronous, right? And this is on a perfect network, sorry, on a 15 Mbps with 5% packet loss. And we are already outperforming the local Wi-Fi catches up. We are already outperforming RPD. So this is both synchronized, same time, same statistical on both sides, left hand and right hand. And you can see that it's smoother, right? That's the goal, right? And then all that, what we talked about, the HTC, the clear coded, the context, or the favorite UFO tests, right? Then it's send it to you.
What was like when you do that?
Yeah. And actually, if it doesn't work, it looks better. I'm sure what's happening right now, but once you get to it, it does seem to work. scrolling text, right? This is something that information was that tool. We can do typing, but I mean, there's definitely level like that. Those frames being not just 5%. And what compromise is that we can get the left hand side, so the right hand side, at 20% back and forth.
So encoder is Microsoft custom, that doesn't mean the decoder.
Oh,
It's
okay.
also
No. So the HTC standard is very loose, okay? When it comes to the code. They don't care how to do the code. As long as you decode, you are able to produce a particular bit stream. Our bit stream is HTC combined. So any device that is able to do HTC can use, right? But you do need a Windows system actually policy in which you to be able to do this, right? There's always those policies with the CPU, and if you're using the legacy app, it also doesn't exist there, right? So that's the natural also. So it's all in the right? But then on the client side, any device that's HTC compliant, I don't know to the whole licensing, blah, blah, blah. If you have an HTC device, you get this, right? This is another example. This is the good point. I want to hold that on for a second. So, okay, so, Bobby goes like that, right? I work for Microsoft. We all like me, right? Microsoft likes them. We want to make things cheap for us in development, right? When we make it cheap for us, that means it's cheap for you as the end user, right? It's cheap for you as the today, right? On the left hand side here. Yes, you can do 4K 60 FPS, but it's typically in code. And guess what? The code doesn't have fair share, right? It doesn't have fair size. This thing don't exist, right? Actually, check it. They do. We build it. But we make it we do have a color fair share, color preemption. So we are able, and this is in the EUCtech, so this is not the Microsoft proprietary, right? It's not there for everybody to use. But now we are able to go on the left side and get a dedicated GPU to serve one user, to where we can do 4 users on the one GPU and give them the experience on the right side. Right? So we're making a better experience for our GPU.
It's for a hard coded.
No.
Okay, so that's just what we've got to right now.
It's always a variable, right? It all depends, right? It depends what type of content you run, but I'm using a very simplified lab example. Like if you're using an A10 today, you can do 4K 60 FPS, 4K 60 FPS for one user. That's it. Like optimal, like the color of the GPU, that's it. That's done. Right? Cannot do more. And then your friend next to you, they have to wait for you to finish and hold whatever you want. Right? That's done. What we've done with the video, we're time sharing that code. So for the first time, with the generation GPU, got a whole NVIDIA, but I also have to come in about 50 years.
Then another 5 years for good drivers.
55 is okay, we are able to boost time size and code, right? And that means that if you have a big job, cube, like we have one of those huge 240 60 FPS frames, we give you 2 milliseconds. They make 2 milliseconds, they have 2 milliseconds, then we get back to you. You don't notice it. They don't notice it. You get an experience while the color is correct. And that's good because we all say that, right? It's more efficient. And the other thing, this goes into Ruben's question, I covered and Commodore, we covered a little bit last year at this event. If you have questions like the policy, it's the adaptive wall latency color. We actually bunch of smart stuff where we detect accounting to show earlier what parts of the screen change. So those back to my previous one from previous statements, only 1% of the time you actually use the 4K system. So when you're smart, and we bring all these things here, you get cheaper, better experience, right? There's much other stuff that we want to talk about. Okay, so this is the supposed to be close, this is, by the way, perfect example of sitting 4-4, right? This is supposed to be yellow. How many people see yellow, right? No, right? But what I want to say, the previous feature saw, briefly, the elements behind, right? Press per second, the freezes, right? The latency, today on the group net, on the group hardware, with RDP or latency, there is no added latency. It's about 7 to 8 milliseconds, in this example, it's 83. So it was 130. With the current we go to the building, or like the teams of the building, we are down to 8, right? And those 15 milliseconds that are saving, that can go to your band, to your network base, right? And sorry, that was with no backup host. Now, in terms of the backup host, there's a whole part, and we really must, right? It's substantially better with cost and the stuff that we do, right? Because we're able to deliver the freeze ratios are 0, because we do those counting with 4 records with multiple reference frames. So yeah, hopefully you will participate in our preview of the next thing, or you can always jump and talk to me about it. I will stop here. We have around 7 minutes, and ready to field any questions, comments, concerns that you might have about what was shared so far. Yes, sir.
I think you go back one slide.
5 bucks.
Is that a type? No? One?
Spelling?
Is it a typo or is that the actual?
No, it's a typo.
Okay, thank you.
That's fine.
You're welcome.
So you can keep it.
Well, that's what I said. You can reach out to me.
It's a good day when the only thing they can ask about is this time.
It's a good one, but also, every good presenter has at least one mistakes, and they get more than somebody notices. For,
You get a nice big shirt.
so you get a free preventive choice. Funny story, when I was in Amazon for a short period of time, and every email that I used to send out, I had like, if you read this one, you get a free coffee. In 2 years, I bought
The emails were so bad.
Probably just long. But yeah, what we did kind of here, like, we do with the machine learning library, all the devices we have, we're going to release models in November that are going to allow you to do that. So that you, as a developer, as a vendor, if you use to set models to achieve the same kind of noisy, you can have quality. In the next thing, which is this new thing that we're building, eventually marketing will be officially. I don't know the next thing, I don't know if that's going to stay, and on the mental banana protocol, which is my point. Yeah. I can say that it actually has I came up with an abbreviation for that. So it goes to banana, right? But what I say, while we were building this for Windows 365 and 80, nothing stops you from leveraging that, right? I just met a gentleman, right? So we will be able to put it there, right? Your encoder, your endpoint, the experience is also this platform that's fully dynamic. We have, I'm not surprised anybody, but we have this thing called the capability negotiation that applicants established. We're bringing that experience in the next thing. We'll be able to see how we're using it from a device that can do 4K 4K 60 FPS, whatever, right? Or you have a GPU, that will give you the best option, right? Using it for your phone, you don't need to focus existing. It's like a user inform, right? And we're able to negotiate capabilities. This is better in color. Eventually, 81, this is the color. We want to be able to dynamically detect that and give you the best possible experience dynamically. And today we started with this, what I call the information worker, not just me, but like a bunch of deployment plans, etc. They call it the information worker type of scenarios. We will extend that outside of those scenarios. That's one of the next iterations of the pod. Questions?
This comes naturally to AV and application. Also, does it run so you can use in your on-premise IPs in the home?
Yeah. So the short answer is the short answer. Yes. Okay. And then I have to go for another 15 minutes in disclaimers. Right? But we are building a platform, right? And can you achieve this on-prem? Sure, but you have the hardware, you have the blah, 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 blah. Install all the possible experience of the world, but we're not trying to create it to Windows 265. It's easier for us to do it with 265 because we can control it. Right? We can give you the right graphics. So this is very independent on the right driver, the right hardware, and if you don't have to host them, I don't know. This is not one computer generation GPUs, right? So when we go GA 2 years from now, whatever, it will be very dependent, like, are you in the right region? Do you have the right hardware to be able to leverage this? Because if you're using like the L40s or and like 8100, those also support it, right? Even the 810, by the way, which is the latest and greatest, they cannot do 444 also. So that's why it's super long. Because if I'm supposed to use the hardware we currently have in Azure, I can do the 444. I need super long to do the 444. Yes, sir.
You mentioned that the information that of all this intelligence that you are building in the server side is in the alpha channel of the encoded bit stream. So you only have to you don't have to read anything else from the platform. You have everything there. If you want to build another encoder or another AI model or whatever, when you said plug and play things.
Yes. So that super Chrome implementation is specific. So it uses an alpha channel, and anybody can do it, right? It's not the APIs are in the Expo for you to be able to do it, right? He's right. Have you done it? No. Why haven't done it? Because otherwise it doesn't before. That's the first time. But if you want to use it, you can use it, right? Now, if your device is not capable of handling all devices are able to do Chrome, right? But if you don't have that command, right, that can only call the configuration, just will not be there. Right? So I'm going to do the 444, right? It goes to my bunch of disclaimers, right? You have to have the Windows app. You have to have the plan for Windows 265 for AD, which is called Windows app. But most of that can handle that information. Now, if you're building a small solution, like let's say
Chrome OS.
Yeah. You need to do the due diligence to implement that, right? And this is why I think this is only for the next 3 years, right? Because we want to make it Mac and iOS and all that stuff, but it's going to take that, right? Next step.
Yeah.
How do you see the world on the server side without GPUs in this whole context of?
Great question. This is why I mentioned briefly, it has taken a lot of time, but this is the platform, right? That needs to be able to handle any possible use case. If there's no GPU, we should be able to use the CPU, and we will bring a lot of these investments, like backflows, handling, when there's pieces, right? If you have to focus XPS, then color, like you got calculated that many pieces, right?
Maybe there will be specific hardware for just encoding.
Eventually,
Maybe. If
it's
it's
something.
big enough.
Yeah, it's something we've been asking the and to build for it, to build for us, right? Is that also the embedded NPU? This is all like a hypothetical, right? There's no concrete plans when this is all land, but definitely
Instead of like an expensive GPU and a cheap CPU, there could be something in the middle.
yeah, let's talk about the tools. Build this summer, that's all.
Build this part. Thank you.
Also, I do have time. I'm here to have any questions, but I need to go figure out the next speaker. So, let me finish. And I have those quotes just there. So, but if you want to speak, I'll be here for 60 minutes and we can show that. Probably, and dan is veldering, je kunt er lang weer chatten.